Okay, now let's take up popping from a link stack. And now I'll write the program for popping from a link stack, and I'll also explain how the pop function works. So now first of all, the main method for this is the same as we did for the push method in the earlier session. So here let's put this iostream.h #include process.h, right? Then struct node. The structure of the node is similar. Int info node pointer next, this is the link, and then you have to take pointers top, new PTR. Actually, new PTR and all this is for the creation of the new node. So when you are writing the whole program, the whole program will have push as well as pop. But now we will concentrate on the pop function, since we have already looked at the push function earlier, right? So now the prototypes, I'll write the prototypes for the create new node again. Node pointer, create node, let's say, and here you pass the integer information, right? And then you have void push. Inside this you pass this is a node pointer, right? And void pop doesn't need any parameters, right? And then void display, and void display again you pass a node pointer, that is the address of the top, right? Okay, now let's come to the main method. Void main, top is equal to null. Always top should be initialized to null, because in the beginning the link stack is empty. It will always be equal to null, right? In the program for pushing as well as popping, wherever you're using this linked stack, in the main method, top should always be initialized to null, right? Then you take int inf, right? Then char ch is equal to y. Here, this one, char ch is equal to y. Then the same loop as we did for the push function, while ch is equal to y, while ch is equal to y, or ch is equal to capital Y, right? Okay, now let's look at this. First of all, we say entered information for the new node, right? This information is taken in here inf, right? After that, the new node is created. New PTR is equal to create node. Here I have written the function as create node. Create node, and inside this you pass this inf, right? Okay. We know how to create the new node. The create node function is the same as we did in the program for pushing an element into the stack, right? Once the new node is created, once that function is called, we check what is new PTR. If it is equal to null, then that means the new node is not created, could not be created, right? New node could not be created, and then you can write exiting, right? Endl, and then you put a exit 1, fine, and then you close this, fine. Okay, after that, one second. Yeah. So here, this, if it is not equal to null, in that case, we call the push method first. The new node is pushed, right? Okay. Then cout. Do you wish to continue? If yes, then more nodes will be pushed, right? So C in CH. So this ends the while loop. End of the while loop for push operation. Fine, okay? Okay. Now after that, you give this system CLS. This is for clearing the screen. Then see, we put a do while loop here. So do cout displaying the stack. Displaying the stack. You call the display function and pass the address of the top pointer here, right? After that, we give a system pause. System pause means it will say press any key to continue, right? So the output will be paused and the user has to press any key to continue, then it will carry on, right? So now here we say cout, do you want to pop an element from the stack, right? Now this is, here is where the stack operation, the pop operation starts. C in CH, you already have that variable CH, so you don't have to take it again. If CH is equal to Y, or CH is equal to capital Y, right? In that case, you just call the pop function. Just call the pop function, and here you see this is the end of the if condition, and since there is only one statement, you can also omit that curly brackets, but if you put that curly brackets, it becomes much easier to understand. Now here, then I close the while loop here, the do while loop, sorry. This is the closing of the do while loop, and here we write while CH is equal to Y, or CH is equal to capital Y, right? Fine. Then that's it with the main function. After this, you can close your main method. I have taken void main, so void main, if we write, we don't need a return 0 and all. If you take int main, then only you have to give a return 0, right? Okay, now let's look at the pop function here. Void pop, right? Now let's assume that there is already a linked list. The create new node function and push function is already done in the earlier session, so I'm not repeating that. Let's assume that the stack is already created. This is the top, right? It has got some address over here, let's say 5643, right? And this node, let's say, is 5643, and here you have got some information and the next pointer. So in the information part, since we are putting an integer, this is 34, let's say, and it is pointing to 1001. So now I have another node here. The address of this node is 1001, and here you have the value 8, let's say, and this is pointing to 9008, right? Okay, let's have one more node, this one. The address of this is 9008, and here let's assume this is the last node, so I'll put some information, and then this, since this is the last node, this will be null, right? So the link is like this. This is pointing to this, this is pointing to this, and this is pointing to this, right? Okay, this is your stack. Now we want to delete, that is pop from the stack. Whenever you do the pop, it's always the topmost element that will be popped out. The first thing I said about stacks was it follows the principle of LIFO, that is last in first out. So the last element that was pushed, that will be the first element to be popped. So when we pop this this one, this will be the first node to be popped, then this will be popped, in that order it will come, right? Okay. Okay, now let's see. You don't pass any parameters for this, fine. If first of all we check what is the value of top. If top is equal to null, what does that mean? If top is equal to null, it means the linked list, the linked stack is empty, so you cannot delete anything, you cannot pop out anything from that, right? So we write cout no elements in the stack underflow. This is called underflow. If the stack is full, we call it as overflow. If the stack doesn't have anything, we call it as underflow, right? Else, if in our case the stack is not empty, so top is not equal to null, right? So we come to the else part. See here, what do we do? PTR is equal to top. So here I'll write it. PTR is equal to top means I get this 5643 here. Top is equal to top next. Top is equal to top next. Now what is the address in top? Address in top is 5643. So when I say top is equal to top next, then top becomes equal to 5643 next, right? So what is 5643's next? The next of 5643 is this one, 1001, right? So this 1001 comes over here. So now what happens is top becomes equal to 1011. So that is gone, and here you have 1001, right? Then after this we write here delete PTR. Now when I write delete PTR, I stored the address of 5643, right? So when we do a delete PTR, now this node, this node is deleted, physically deleted from the stack. Fine. And then we close this. This is else, so else is closed. After that this function is closed. So now you see the links. I'll put the links again here. Now you look at this. 1001 is this one, right? So 1001 means it is pointing to this one now, right? And 1001 is pointing to 9008, so this is there. So basically what has happened is this link is gone, right? It's like this. This is not there. This node is already deleted, so this link is also not there. Understood? So this element has been popped out, right? After that, again, when you go back to the main method, I think, sorry, this one. Here, while choice is equal to y or y, displaying the stack, again it will display the new stack. And then do you want to pop an element from the stack? If the user enters y, I'll again go back to this place, right? Now the same thing will happen. You will come to the else part. PTR is equal to top. Now see what will happen. What is PTR? PTR is equal to 1001 now, right? And PTR is equal to 1001, and I say top is equal to top next means top becomes equal to 1001's next. So 1001's next is 9008. Okay, and then we say delete PTR. So basically now the next time when I do it, this 1001, this becomes equal to 9008. Fine. And this delete PTR, PTR is 1001. So basically this node is also deleted, right? And now again the links are redefined. Now here what happens, this one 9008, sorry, PTR is equal to, I put it wrongly, 1 minute, PTR is equal, okay, PTR is equal to 1001, right, top is equal to, here 9008 is here, right? So this is the link now, 9008, fine. So here again this link is also gone now. This link which we had made, that is not there, right? And since this node is deleted, this link is also not there. So now you have popped out 2 elements deleted, then there is only one element in the stack. Like this it will continue. When it comes to the last node, top will become equal to null. So next time if you call the pop function, if top is equal to null, it will say no elements in the stack, right? So this will continue until there are elements in the stack, it will be deleted, right? So this is how the pop function works. So we have seen how to push elements into the linked stack in our previous session, and in this session we have seen how to pop elements from the linked stack. So with that I end this session.